Hi! Hold on, turkeys. Let me find my stuff here. Okay. Shall we? Shall we? Okay. Today you are going to do these notes. Before you do these notes, you have a formative to do. I hope you did it. It is not for a grade, but it needs to be done. And then you're going to take these notes and do this ed puzzle at the same time. And then you have a simulation to do, and be kind of fun. All right. Let's see. Unit 4. We're going to start talking about the moon and the sun and the Earth, Sun, Moon system. Okay. This is a picture. You guys might recognize this. This is the solar eclipse, right? Pretty cool. This is what it looked like if you looked through those glasses. Okay. So, what is the deal with that slide? In our Earth Moon system, here this is the teak. Okay, so we're going to model. There's so much modeling. How the orbit and relative position of the moon cause lunar phases and predict the timing of moonrise and moonset during each phase. And we're also going to model how the orbit and relative position of the moon cause lunar and solar eclipses. Okay, so first of all, we're going to be seeing a lot of diagrams like this. And I know y'all have seen them before. I taught 8th grade one year, and it was the worst year of my life, but I taught this there too. We're going to get way more in depth. Okay. Also, I hope you all know that the moon is kind of rare. Like, not many planets have a moon like we do. Okay, it's really big in comparison to most other moons, and compared to Earth. Okay, and so we know that the moon goes around the Earth, right? And we both go around the sun. So that makes things kind of, I don't want to say tricky, but less simple. Okay, it makes things a little bit complicated. Okay. Also, there is not a dark side of the moon. Okay, but the moon, all of the moon gets light, but there is a side that we don't ever see because the um, the moon always faces us in the same direction. It's locked there by our gravity. Okay, so it does rotate, but we end up seeing the same side of it all the time, and it looks like this, which I'm sure you guys recognize. This is the part that we don't see. Nobody on Earth sees this part. It does get sunlight though. Okay. All right, so the moon changes phase. That just means its appearance changes. It's not changing. Okay, in a cyclical manner because of its rotation around the Earth and both of our rotation around the sun. So we change in relation to the sun. The cycle repeats every 29.5 days, which might make you think that that's how long the moon takes to go around the Earth. And that's not true. I had to look this up. I didn't know this. The moon takes 27.3 days to orbit the Earth, but during that time, the Earth moves just enough so that the whole cycle needs 29.5 days. Okay, kind of interesting. Half of the moon is always illuminated, just like half of the Earth. Okay, so there's always half being illuminated. So when we move around like this, okay, it's always half. It doesn't look like that from Earth, and that's kind of what we're talking about. The only thing that's changing is that our perception is changing. the way that we see it. Okay. The phase depends on how much of its sunlit hemisphere is facing the Earth. Okay. All right. So we have this. This is the phases of the moon. We are in the middle, right? Is this to scale? No, it's so not to scale. The moon's almost as big as the Earth. Okay. So not to scale. So we're going to start over here when we see a new moon. Okay. And in this class, we're usually going to talk about that as the beginning of the cycle. All right. Of course, it's a circle. It's a cycle. So, the full moon is also the beginning of the cycle, right? So just keep all that in mind. This is where the sun is on this diagram. Okay. So let's take a look at the new moon. Half of the moon is lit, illuminated. In fact, let's talk about that right now. The moon is illuminated by the sun. It does not give off any of its own light. All right. It's not making light. It is just reflecting light. In our solar system, the sun is the only thing that gives off light. Okay, so I know that we can see Venus and it looks like a star. A lot of the planets look like stars, but what we're seeing is light reflected from the sun. Okay, so in the new moon, the illuminated part of the moon is facing the sun. The unlit part of the moon is facing the Earth, and so we don't really see anything. Does that make sense? We're seeing the back and it's up against the sun. It's also usually out during the day, so we're really not seeing it. Okay, then we have a waxing crescent. Okay, the word waxing means getting bigger. Waxing means getting bigger, and waning means getting smaller. So what's happening here is that we are going in this circle and we're going from a new moon where we're just going to say there's no moon. We're getting a little bit bigger, a little bit bigger, a little bit bigger until we're full. We're waxing this whole time. And then we get a little bit smaller, a little bit smaller, and a little bit smaller until we're at a new moon again. Okay? So that's what the waxing is and the waning. We're going to fill out a chart on this in just a minute. Okay. So that's what's happening there. Also, I want you to notice, do you see how up here where we're waxing, everything's on the right side. Okay. For here where we're waning, it's on the left side. Okay. Waning is the left side. And waxing is the right side. Okay, so we have the waxing crescent, and then we get a little bit more full, and now this is the first quarter when it's halfway illuminated. Then we get to the waxing gibbous. Okay, the gibbous moon is kind of the opposite of a crescent, and I like to show you guys a picture of a gibbon, like making this vocalization where they like puff their throats out, and it looks like this. They look like a big bullfrog. I'll show you that picture sometime soon. But the gibbous is getting fuller, but it's not quite full. And when you look at the moon through a telescope, sometimes it looks like it's really full. It's technically only full like one night. You can see like part of the moon will be fuzzy. Like this line over here will be very sharp, and then this line will be kind of fuzzy. When you have a completely full moon, like sometimes this little sliver that's dark is very, very small. When you have a completely full moon, you'll have a sharp, crisp edge all the way around the moon. Okay, then this side starts to get fuzzy. Okay, and then we're waning. So the waning gibbous, the light goes away from this side, and so we have the light on the left side. Then the third quarter, and then the waning crescent. Okay. Okay. Waxing is getting bigger. It is always on the right. Okay, I thought that I had made those slides a little different, but I didn't. It's getting bigger. It's always on the right. Okay, here is looks like a first quarter moon. This is a waxing gibbous moon. This is also a waxing gibbous moon. So if this was just flipped around, it would be a waning gibbous moon. Okay, just depends on what side of the moon is illuminated. That's how you can tell if you're waxing or waning. And that's going to be important when we have a test and I ask you to identify part of or what phase the moon is in. Okay, so this is what's happening here. From Earth, we are seeing the moon from the side. Okay, so what we're seeing is this. It's all just because we're looking at the moon from Earth. If you were looking at it from the sun, it would be a full moon all the time. Okay, then waning is getting smaller and it's always illuminated on the left. So you can see here, there is some shadow over on this side, some shadow over here. So the left side is illuminated. This looks like a third quarter moon. So does this. Okay, this is a waning gibbous. Okay, always on the left. Okay, and then we have something called moonrise and moonset, just like sunrise and sunset. And we talked about how the sun rises at different cardinal directions during the year and on certain days. So the moonrise and the moonset, it just goes with the cycle. Okay, so when we have a new moon, it rises near sunrise and we can't really see it. We're looking at the back that's not illuminated and we can't really see it ever. It's possible, but you have to have very specific conditions. And then the full moon rises around sunset. And then, of course, you can look up all of this stuff. You can see all of this. So this is saying right here, this is a new moon, and you can see that because it's a black circle. Okay, so it looks like we're coming up here on the first quarter moon on the 8th. So when we had a new moon, the moonrise was at 7:53 a.m. And then the next day it was at 8:51, and that's because we switched the time zones, or not the time zones, but the daylight savings. That was this weekend. Okay, and then we're going to come down here, and so when we're at the first quarter, it's at 1:10, and these are pretty predictable. The full moon rises around sunset. We're going to talk about some of these things later, but just know that you can predict the moon rise and the moon set, and that it changes according to the phase. Okay, that's it. Actually, that is not it. We are going to do a chart together, okay? I can't figure out how to turn it off.